Welcome back to Forge College. First things first, massive congratulations on surviving the navigational flowchart lesson. I know, we made it through that absolute logic maze, right? But now, we've arrived at the main event. In today's explainer, our goal is pretty straightforward, but super important. We're going to take all those brilliant, but, maybe slightly chaotic, drawn on a napkin at 2 a.m. kind of drafts we've been working on, and finally synthesize them into one perfectly polished, presentation-ready capstone diagram. We're literally mapping out the core architectural differences between Ethereum and Bitcoin, and then we're going to really reflect on what those differences actually mean for system design. Let's get into it.
Here's our master blueprint for today's review session. We've got 1. The capstone synthesis. 2. The 5-pass polish. 3. Verifying your masterpiece. 4. Reflecting on trade-offs. And 5. Wrap-up and next steps.
Starting off with Section 1, the capstone synthesis. Let's combine those drafts.
Okay, so let's dive into this. Before we draw any final lines on the page, we need to completely anchor ourselves in exactly what goes on either side of our architectural schematic. Now, on one side, we have Ethereum. Its entire world revolves around an account-based state. So think of that like a dynamically updating ledger. And right alongside that, you have the state DB, and of course, the absolute execution powerhouse, the EVM. But then, look at the other side. We have Bitcoin. Its architecture is built entirely differently. It leans heavily on the mempool and the UTXO set, which functions a lot more like handing over specific combinations of physical cash. And naturally, it features its intentionally constrained script engine. Your diagram really needs to put these two radically different approaches right side by side. You want anyone looking at this to instantly visually grasp how they intake, validate, and store transactions.
Moving on to Section 2, the 5-pass polish. Time to refine that diagram.
All right, so here are the 5 passes we're going to execute. We go in this exact specific order for a reason. Working in focused sequences prevents us from, completely breaking our layout while we try to fiddle with the tiny details. We'll start with a layout tidy, then move to metaphor consistency, nail down our labeling, attach our source notes, and finally, run our legibility tests.
So, pass 1 is the layout tidy. For this, I want you to zoom way out. Really look at the big picture. Use your alignment grids to keep related components perfectly aligned across the horizontal axis. A reader should literally be able to draw a straight horizontal line to compare transaction intake on Bitcoin directly with transaction intake on Ethereum. And listen, you have to be totally ruthless here. Eliminate any redundant arrows, completely scrap the decorative elements, and standardize everything. We are going for clean, absolute technical precision.
And that brilliantly illustrates why Pass 2 is so absolutely critical. Metaphor consistency. Now, a visual metaphor is basically just a consistent graphical device that tells the reader what a shape means without them having to read the text. It's like a visual shorthand. For example, maybe using a layered stack for client software or solid boxes for data stores. The rule is, if you use a stack for Ethereum's client, you must use that exact same stack shape for Bitcoin's node software. No exceptions. You also have to strictly document these metaphors in an embedded legend right on your diagram. Literally no guessing allowed for the reader.
Moving right along, we're actually going to combine passes 3 and 4. This is the point where you swap out those provisional, messy draft labels with exact, authoritative terminology. So don't just call it a waiting area, call it the TX pool for Ethereum and the mempool for Bitcoin. Then, for any ambiguous technical claims you're making, attach a small numbered superscript. That specific number needs to map directly to a compact source note, sitting right at the margin of your document, and that note should link back to the authoritative specs or developer guides. Finally, we hit Pass 5, legibility tests. We are exporting this whole thing at 2 distinct sizes, 1920 by 1080 for full presentations, and a tiny little 600 by 338 thumbnail. And I'm going to warn you right now, if your reviewer needs to pull out a high-powered microscope to read your labels at that thumbnail size, you have completely failed the test. If that happens, you must increase your font weight, reduce your line length, or just totally adjust your layout to prioritize high-level readability. It has to be crisp and clear.
All right, on to Section 3, verifying your masterpiece. You've drawn it, but now let's test it.
To formally verify your work, we use this quality assurance checklist. And honestly, I challenge you to act as a first-time reader here. Open your exported file and try to physically trace a transaction path on both the Ethereum and Bitcoin sides without relying heavily on your legend. Check your label completeness, like, are all the core components actually there? Check your metaphors. Are there any weird contradictions? Check legibility, and make absolutely sure that every single superscript number maps to a valid source citation.
If you can trace the flow cleanly and confidently, you pass.
Section 4. Reflecting on trade-offs. This is where we move beyond just the drawing board.
We are pivoting here from the how of drawing to the why of system architecture, and I really want to pose this question directly to you. Why does this visual contrast actually matter? The difference is you just spent all that time mapping out, like Bitcoin's UTXOs versus Ethereum's account-based state. They're not just visual decoration. They represent massive, system-altering design consequences that fully dictate how these networks scale, how they're secured, and exactly how developers have to interact with them.
Your written reflection needs to be packed with crisp, direct, causal statements. Take this quote as a perfect example. Because Ethereum uses an account-based state and the EVM executes arbitrary code, node operator storage demands grow faster than Bitcoin's UTXO set. See that? That clearly links an architectural reality, Ethereum's account-based state and the EVM, to a very concrete consequence, the rapid growth of node operator storage demands compared to Bitcoin. It's cause and effect, plain and simple. Hits a nail right on the head.
And finally, Section 5, Wrap-Up and Next Steps. Let's get this submission finalized.
Before you submit the whole shebang, let's quickly summarize the 3 main takeaways that should really guide your architectural thinking moving forward. First up, representation matters. How a state is actually structured dictates how we can prune it and scale it. Second, execution differences are everything. The EVM allows for this incredibly brilliant programmability, but it also vastly increases the network's attack surface when you compare it to Bitcoin's limited script. And third, fee models aren't just dry economics. They fundamentally alter user experience and change how wallets actually must be designed. So yeah, these diagrams, they have massive real-world utility.
To officially cross the finish line for this milestone, you need to package your work into a formal submission bundle. You just need to make sure it contains these 3 specific deliverables. Number 1, a high-resolution PNG or PDF of your polished diagram. Number 2, the editable source file itself so we can actually see how you built it under the hood. And number 3, that 250 to 400-word reflection document we talked about. Just make sure you name the bundle exactly as the project conventions outline.
And once that's submitted, well, are you ready to see how the EVM processes these highly complex state transitions in real time? Because that is exactly what we are going to be tackling in the very next lesson. You'll actually bring this exact diagram as a visual anchor when we dive super deep into bytecode and gas metering. Until then, thank you so much for joining me for this explainer. Remember to visit us at forge.college to explore this subject even deeper and discover way more incredibly detailed content on all things Web3. See you in the next one.